Nomenclature of alkyl halides. Alkyl halides are named in a similar way as the corresponding hydrocarbons. The rules, many of them are the same. There are only slight differences depending on the new element which was added in the chain, that is a halogen. Alkyl halides are named as derivatives of corresponding alkanes, and the position number is inserted to denote the position of the halogen atom on the chain. Numbering a carbon chain starts by the extremity of the chain closer to the halogen. This is what we have called the lowest locality rule. In the case of many different halogens, they are written in alphabetic order, while in the case of one halogen present on different position, the prefixes D, tri, tetra, and others are used to indicate how many halogens are in the chain. And the halogens are written as substituents. That's why their name change from chlorine, bromine, fluorine to chloro, bromo, fluoro, and iodo respectively. Let us have examples. Our first example is CH3I. In this molecule, we have two names. One is a systematic name, another one is a common name. Let us see how we have constructed this systematic name. The molecule is composed by two main groups. There is CH3 and there is I. The I is a halogen whose name is iodine, but because it has been a substituent on this molecule, it has changed to iodo. And CH3, it is a group which came from the alkane whose name is methane. So if we combine the two parts, we reconstruct a name which is iodomethane. Conclusion: to construct the name of an alkyl halide systematically, we write the name of halogen followed by the name of parent alkane, and the halogen here is iodo and the parent alkane is methane. So the name comes as iodomethane. Second example, we have CH3CH2 which came from ethane, and we have halogen which is chlorine. So to construct the name, we write the chloro and we add the name of parent alkane, ethane, and the name become chloroethane. Third and fourth example, we have two halogens in the chain having two carbons, but these two halogens are not on the same carbons. For the first example, the two chlorines are attached on the same carbon. That's why in the name we indicate their position by saying 1,1-dichloroethane. 1 indicates the position of halogen, while D indicates how many they are. They are on the first carbon and they are 2. That's why the name is 1,1-dichloroethane. For this example, we have again two carbons, the chain, and the two chlorines in the molecule, but the two chlorines are not attached on the same carbon. One is on its carbon, another is on its carbon. It means that if one is on the first carbon, another one will be on the second carbon. That's why the name will be 1,2-dichloroethane. 1, the first carbon, 2, second carbon, and D to show there are two chlorine atoms. Conclusion: if the position of a halogen can change and form a new molecule, it is a must to indicate that position in the name. But if this is the only way you can put that halogen in the molecule, is not a must to indicate the position of that halogen in the chain. For example, if you look at this molecule, chlorine can be either on the first carbon or on the second carbon, but when you number the chain, always it will be the same name. Or it can be here. So if you are to name the two molecules, they will have the same name, because this will be 1 and 2. Again, this one will be 1 and 2. And all of these molecules will give the same name here. The fifth example, we have carbon and 4 chlorine atoms. When you look at this, you cannot know this is an organic compound, but it is. You can see that the 4 hydrogens of methane have been replaced by 4 chlorine to form this alkyl halide. That's why the name will be tetra, to mean 4 chlorine atoms, methane, because the parent alkane was methane, tetrachloromethane. And the last example, we have 3 hydrogen of methane have been replaced by 3 chlorine atoms, and the name is 3, to mean 3 chlorine atoms, methane. So we can also talk about the common names. Generally, when we name the alkyl halides using common names, we are naming them as we name the inorganic salts. Here I use an example. This salt is very common and its name is sodium chloride. But the way the name is constructed, you take the name of metal, sodium, and you add the name of halide, chloride, and they form sodium chloride. The same will apply with alkyl halides. If I have a CH3, Cl, the CH3 will be taken as metal sodium, and the chloride will be as a halide. So as I said, the sodium chloride was the name of this inorganic salt. Also, this alkyl halide organic compound can be named the same way, where this one is called methyl and this one is called chloride. So the name of molecule will be methyl chloride. But this way of naming is recommended when you have only one halogen in an organic compound in a given chain. But if you have more than one halogens, please use the systematic name. It is better. Let us name these examples. The first example, we're going to choose first the parent chain. And the parent chain is the chain which contains many carbons and it has a halogen in it. For our example, the chain is containing 6 carbons and it has 1 halogen, which is bromine. Second step is numbering the chain by making sure that the halogen is taking the lowest position possible. So that's why I'm going to number from here: 1, 2, 3, 4, 5, and 6. With this direction, bromine is on the 3rd carbon, while the other direction, bromine will be on the 4th carbon. So this is the right direction. After you assemble the name, to write the name, you have first to write the position of the halogen. 3 hyphen the name of halogen, which is bromo, plus now the name of parent chain, which is hex, A-N-E, hex because it has 6 carbons, N-A-N because it has single bonds, and E because it is hydrocarbon. So the full name will be 3-bromohexane. So as we go to the first example, we can name together the second example. Here we have a parent chain composed by 3 carbons, and you have 2 halogens, bromine and the chlorine. So the thing we have to do now is numbering the chain. But because the 2 halogens are giving us the same positions from different directions, it's better to give one of them a priority. So we have a bromo and the chloro. B comes before C. So we give priority to bromo because this one comes first in alphabet. So we are going to number 1, 2, 3. So after numbering the chain, so we can now construct the name by writing the position. Again, when you are listing the names of halogens, you have to list them alphabetically. We saw it in the rules previous slide. B comes before C, so we'll start by writing 1 bromo, then 3 chloro, and the name of parent chain is prop, cause 3 carbon, A-N-E. Now the name will be 1 bromo, 3 chloropropane. It is simple, right? So we can also name the other molecules. For example, this one has 1, 2, 3, 4, 5 carbons, and it has bromine, so this may be the parent chain. While here we have a branch methyl. So when we are going to name it, we have chosen the parent chain already. So we are going to number the chain by respecting the rules. 1, 2, 3, 4, and 5. We have 2 substituents here. We have a bromo and you have a methyl. We have to order them alphabetically. B comes before M. That's why now the name will be 1, bromo, 1, 2, 3, 3 methyl, and then the name of parent chain is pentane. So we'll have the full name, which will be 1-bromo 3-methyl pentane. Got it? We can name this one. When now the parent chain is cyclic, we have always to make this carbon which has halogen number 1. And it's 1, 2, 3, 4, 5, and 6. And then we constructed the name by starting by writing the name of the halogen with its position. It's 1. Chloro. And the name of parent chain, because we have a 6 carbon in the chain, it is hexane, but because it is cyclic, we added the word cyclo. Cyclohexane. Good. So the last example is this. We can have a double bond or a triple bond in the parent chain. When we are numbering the chain, we give priority to the double bond instead of halogen. That's why numbering this chain will be 1, 2, 3, 4, 5, yes, instead of being 1, 2, 3, 4, 5. If we number from here, it will be showing that we have given priority to this halogen, while it was supposed to be given to the double bond. So the halogen is taken as a substituent, while the double bond is taken as the functional group. So that's why the double bond is the one to take priority over the halogen. Then after numbering it, we constructed the name like the way we did it in the previous examples. We first write the position of halogen, so it will be 5 bromo, and then 1, 2, 3, 4, 5 pent. This time on, we are not going to write AN because it's not single bonds only, we have a double bond. That's why now we write the position of double bond, which is 2, and we write En. This En, it is to show there is a double bond, and the E, which is to show it is a hydrocarbon. So the name become 5-bromo pent 2-En. It's time for you to evaluate yourself, your skills about naming alkyl halides. Here we have 2 molecules. Take 2 minutes and name them, and you will compare your names with the ones we will have found when we are naming them together. Okay, now let's name the first molecule. So as we saw it in the previous examples, we have first to choose the parent chain. So our parent chain is composed by 2 carbons, and we number the chain from the left to the right, 1, 2. You can ask yourselves why we have not numbered them from the right to the left. It is because we are respecting the lowest sum rule. You can take your time and name it by numbering from the right to the left and compare the name with what we have found here. Yes, now after numbering the parent chain, so we identify the substituents, which are chlorine, bromine, and fluorine. Chlorine, bromine, and fluorine. Bromine comes first in the alphabet. That's why we start with bromine, 2, bromo, and then next is chloro, 2, chloro, and now we have 1, 1, 1, 3, fluoro, and the parent chain is composed by 2 carbons, so it is ethane. So the name is 2-bromo, 2-chloro, 1,1,3-fluoroethane. Good. Second molecule, the parent chain is and we number the chain from the right to the left. 1, 2, 1, 2, 3, 4, 5, 6, and 7. After numbering the parent chain, we identify the substituents, which are 2 bromine atoms and 1 methyl group. B comes before C, so the name will be 2 and 4 D-bromo, 5 methyl, and the parent chain is composed by 7 carbons, so it is hept Ne. The name is 2 and 4 dibromo 5 methyl heptane. So this is the general rules of naming alkyl halides. We can have many other examples, so you will try them and identify the challenges, and if you have any question, please don't hesitate to ask.